Ivan Ostromislensky, Ivan Ivanovich Ostromislensky, Russian, Ivan Ivanovich Ostromislensky, also Iwan Ostromislensky, 9 September 1880, 16 January 1939. He is credited as the pioneer in studying polymerization of synthetic rubber as well as inventor of various industrial technologies for production of synthetic rubber, polymers, and pharmaceuticals. Early life. Ostromislensky was born in Oryol, Russia, to a family of a nobleman, a porotchik of elite corps. He received his education first at the Moscow Cadet Corps and then, from 1898 to 1902, at the Moscow Technical School. After graduation in April 1902, Ostromislensky went to Germany and enrolled to the technical school in Karlsruhe. There, he specialized in physical chemistry, organic chemistry, and electrochemistry. In July 1906, he returned to Russia, and in February 1907 was hired at the Moscow. In 1909, Ostromislensky became a private student of MSU. During his work at MSU, he actively collaborated with Professor L. Chugayev, who headed the Laboratory of Organic and General Chemistry, and started his work on synthetic rubber. In 1912, after an internal quarrel, Ostromislensky resigned from the MSU. He continued his work on rubber 1912-1917 at Bogota, Russian, Bogota, which was Russia's main rubber company. The company director showed great interest in the emerging synthetic rubber and readily financed the work of Ostromislensky, who was the pioneer of synthetic rubber in Russia. In 1905, Ostromislensky started reporting his research on the polymerization of dienes and on the synthesis of the starting monomers for synthetic rubber. He had patented more than 20 ways to produce butadiene butaminous-13 diene, which were implemented industrially in the Soviet Union. The butadiene production method, which was based on aldol condensation of acetaldehyde 1905, was also implemented on industrial scale in Germany in 1936. Another method was based on passing vapors of ethanol and acetaldehyde at 440–460 deg C over aluminium oxide 1915 and received industrial use in 1942–19. In 1915, Ostromislensky also synthesized isoprene via pyrolyses of turpentine and polymerized it using light. Ostromislensky pioneered the studies of non-sulfur activators of vulcanization of rubber. He also proposed organic additions to rubber, such as toluidine and naphthylamine, in order to improve its properties. Those additives were later exploited by U.S. companies, such as Union Carbide. In 1913, Ostromislensky published a book on rubber and its analogues, which was the first Russian textbook on chemistry and technology of rubber. It summarized most available bibliography on the subject, including foreign patents, which were inaccessible to most Russian readers. The book also described 16 original methods of industrial synthesis and polymerization of dialkenes-alkadienes. In 1910s, Ostromislensky also started shifting his attention toward biochemical, immunochemical, and pharmaceutical research, as indicated by that he had 2 doctoral degrees from University of Zurich in philosophy and medicine. In 1913, he started his own company named Private Chemical and Bacteriological Laboratory. There he performed a number of studies on the immunological specificity and chemical nature of antibodies and antigens and published the results in the Journal of Physical and Chemical Society in 1915. Ostromislensky investigated the possibility of synthesis of antibodies in vitro and proposed a theory of antibody synthesis, which is regarded as one of the first versions of the so-called matrix theory of antibody synthesis. The theory had strong influence on the development of immunochemistry, but was later proven incorrect. Medical interests of Ostromislensky are also illustrated by his essay on dream in humans and animals, which examined the toxicological, immunological, and physiological aspects of a dream. He considered sleep as a process of self-poisoning by some toxin, which shortens the lifetime. Between 1918 and 1920, Ostromislensky headed a chemical therapeutic laboratory of the Chemical Pharmaceutical Institute in Moscow. There he studied the structure and properties of the popular foreign drug salvarsan and developed the method of manufacturing a domestic analog called arsol. Arsol was based on relatively cheap production of colloidal arsenic that was important in the time of the civil wars and economic crisis in Russia. Life abroad. In October 1921, Ostromislensky left Russia and moved to Latvia. There he assumed a position of assistant professor at the Department of Organic Chemistry of University of Latvia in Riga. There he taught two major courses, on chemistry of rubber and on chemotherapeutic drugs. In May 1922, at the invitation of Dr. A. Hopkinson from the U.S. rubber company, Ostromislensky moved to New York. There he continued his work on chemistry and technology of rubber and pharmaceuticals in two companies, United States Rubber Company and Goodyear Tire and Rubber Company. In 1925, he opened his Ostro Research Laboratory, where he studied the pharmaceutical properties of various compounds based on arsenic and vegetable oils which were used to treat leprosy. He also advocated commercial production of chemotherapeutic drugs pyridium and pyrazolone. In 1928, he received a U.S. patent for production of polystyrene, which was used by U.S. Rubber for the first commercial production of polystyrene. He also patented his early work on the synthesis of polyvinyl chloride in the U.S. In 1930, Ostromislensky received U.S. citizenship and was invited to work in the company Union Carbide to develop commercial production of butadiene from ethanol. The production ceased only after the World War II because it could not compete with butylene-based technologies. In the U.S., Ostromislensky improved several industrial technologies of synthetic rubber production. He also developed a technology for producing safety glass for the automobile windshields. In one of developed by him reactions, ethanol is oxidized to acetaldehyde, which reacts with additional ethanol over a tantalum-promoted porous silica catalyst at 325–350 deg C to yield butadiene. CH3CH2OH plus CH3CHOCH2 equals CH equals CH2 plus 2H2O. This process was used in the United States to produce government rubber during World War II and remains in use today in China and India. Death and legacy. Ostromislensky died at the age 58. His scientific work did not receive appropriate recognition during his lifetime, but was widely praised afterwards. He was among the first 5 scientists inducted into the International Rubber Science Hall of Fame. References